We're going to be starting with a talk about telemetry, and I'm going to be introduced to our next speaker. Ayo, please come forward. Thank you, my friend. Ayo works for Dropbox, and he has long experience in analyzing telemetry and doing different types of SOC, and then he's working for the incident response team, the detection and response team. I was talking to him yesterday, and we were having this very interesting conversation because there is something I'm wondering. You are 26 right now, right? Yeah. Which is very impressive, right? For speaking at this age, speaking at the conference like this one. And I was wondering, I've always been wondering, how do you actually understand technology when you haven't gone through, I've been living the Unixes and all the beginning of technology, so I can actually understand things. And I've been always wondering if you're a younger person, how do you do that? And Ayo amazed me yesterday with one of his hobbies, which actually touches to the topic. So can you share this amazing hobby of yours?
Yeah, sure. So I like collecting vintage technology from the 90s, early 2000s. Think Panasonic AG500. It's a CRT computer. Well, it's a CRT monitor specifically that has a handle at the top. You can put a VHS tape to the side, and it's got RGB cables behind it as well. So if you got a Sega Mega Drive, you can play Sonic and stuff with really old and vintage grainy visuals. And another thing that I own is this Casio wristwatch that was released in the 90s, I think, and it's got a camera at the front of it where if you point it at something, it takes a photo. And it's a really grainy photo, but I just thought it was the coolest thing in the world, so I bought it.
But that was in the 90s?
Yeah.
Wow, that's impressive. Yeah. Okay, so basically, as I say, the curiosity and the interest for things, how things work in the backstage and why we are here, I think that's one of the most valuable things we have in our community, right? So, Ayo, thank you very much for being here today. The floor is yours.
Thank you.
Thank you.
Hello, everyone. Get started. So my talk is on macOS telemetry versus EDR telemetry. Take SentinelOne, Rapid7, CrowdStrike, comparing which is better. The macOS telemetry I'll be going through with you today is the unified logs. Who am I? I'm a security engineer, as Jeff said. Before that, I worked as a detection response analyst at MDR in Rapid7 doing malware analysis, IR, and alert triage. So the agenda of today's talk, we're going to be talking about what are unified logs, answering some investigative questions with those logs, talking about private data logging, log retention, and comparing the unified logs versus EDR telemetry. I will go through takeaways at the end of the talk. So what are the unified logs? They're basically Apple's system-wide logging framework that pretty much just captures everything imaginable on an Apple device. And as you can see there, it's on multiple different Apple platforms from iOS, macOS, tvOS, and one of the speakers did a talk on home devices. Apple has their own home hardware as well that contains unified logging as well. Basically, it's just a centralized logging platform that contains anything you could possibly think about, any processes, it's there. This talk will primarily just be focusing on the unified logs on macOS rather than unified logs on iOS, which is something that already exists. So where are these logs stored? Stored in multiple different locations. The first is on disk at these various different locations here, as you can see. And the main way of exporting these files is via a log archive that you can see here. And that basically is just a compressed version of all the logs that exist on the host. And you can imagine it's quite voluminous and quite large. Another location where this exists is in memory as well. Pretty much just shared ring buffers on a Mac host. And it's important to note that since RAM and memory on a host is quite volatile, the log retention of logs that are contained in memory are going to be very low. It might even be maximum a few minutes, a few hours, or a few days. So how do we access these logs? Two primary methods of accessing these logs. The first one is via log stream. And that basically streams all the events or all the processes that are happening on your machine. Let's say you wanted to focus on processes associated with the window manager, like when you grab your window back and see what that's doing. You can literally just do that using log stream, and you can see everything that's being logged to the computer. Another way to access this is via log show. And for forensic analysts, we usually like timestamps and converting our local timestamps to UTC. And thankfully, this command line tool provides that. It's also important to note that this tool exists pretty much out of the box. You don't need to install anything. You don't need to download anything. It comes prepackaged with the macOS operating system. And let's talk about an example of what these logs look like. I've broken down this example log that comes from the Windows server. And the Windows server is basically the window of your application that you're looking at. And as you can see here, you can see the timestamp, log level, in this case it's error, process ID, so you can filter on that too. And the name of the process. The sender could be, which is pretty much the library that this Apple process is using. The subsystem, which is also related to the library, but it specifies more specifically what the library is rather than what the sender is. There's also the category. This could be like a function or a class within this library core animation that the log line is calling pretty much. And then finally, there's an event message just showing you what was discussed and what was entailed in this log. And it's just that the timer was delayed. And if in the case you want to filter on these attributes that I showed in the previous slide, you can literally do that using what's called log predicates. Log predicates allow you to filter on things like process ID, process, image, image path. So let's say you believe a piece of malware exists within the temp directory or user's download directory, you can filter on that path specifically and get information as to what kind of logs you can get from that specific path if you know malware exists there. You can also filter by library in case you have a malicious library that exists somewhere on the host. You can filter by that too. And also the event message, which I'm going to show you guys what that looks like when you do investigations. So an example of how you can use log predicates. I have the predicate provided to you here. Basically, I'm just filtering on the subsystem Apple com login window. And I'm filtering by auto launch items. And as you can see here, we can see two auto launch items on my host, which is just the Dropbox app and the Dropbox Dash app. I literally just did this using the log show command that can be seen here. And you can imagine if you have a case involving malware persistence and you want to know where that persistence mechanism is located on the host, you can use it. You can literally just use this command line here to see where that persistence is located or what even persistent items exist on the machine. Next slide. So let's look at exporting these logs. The first primary way of exporting these logs is via just log collect. You're going to notice a common theme, a pattern here, and that's that Apple pretty much provides you with a lot of the command line utilities for accessing these logs and manipulating them. Well, filtering through them specifically. And as you can see here, when you run log collect, it's going to write out to a log archive, which is just Apple's proprietary compression format for holding these logs. You can also provide a start date, end date, or last, which is basically like last minute, last hour, last day. You can also provide a time zone as well. You're more than likely going to want to convert that to UTC. And you can also use a predicate to collect all the logs on AirDrop, for example. You don't need to use just AirDrop. This is just an example. You can pretty much collect just the logs on whatever process you want on the system. Other things that are worth discussing is you can also choose to output the contents of log show or log stream to a file if you want to export it that way. That way you can add some styling to it like JSON, NDJSON, or syslog styling. And all of that is pretty useful for investigations. So let's compare the difference between log stream and log show because this is really important. The fundamental difference between log stream and log show is that when you run log stream, you're just going to get the things, you're going to get the things that are in memory and the things that are on disk. And as you can see here, the things that aren't persisted are the debug, bug, and info logs because those are primarily living within memory. Everything below that is on disk as well, and like it's only persisted up to a certain storage limit. And luckily, Apple allows us to modify what is logged on the host, but it's also important to keep in mind that depending on how high of a logging level you go, performance on your host is going to be degraded slowly, and the amount of logs you retain will also reduce as well. And I'll explain that in the further slide. These are some common EDR tools that collect the unified logs by default. Yeah, you know some of them. And a really good one is Velociraptor. That's one that's been talked about a lot today. That provides unified log parsing for you. But with that, you do need to provide a predicate before you can even parse those logs, because the unified logs are very much a fire hose where, like, if you try and collect everything, it's going to be too much far too untenable to analyze. So let's answer a few investigative questions. In this situation, a user enabled screen sharing, which is the macOS remote access feature that comes built in with the operating system, similar to like AnyDesk or TeamViewer, but think just it's on Mac. They enabled this and they accessed a host from the internal network. And you can see by using this predicate here, in particular where we focus on the screen sharing D process or the screen sharing agent process, I just checked for succeeded messages. We can see that the analyst was able to log in from this remote IP here. And it was indeed successful. Another investigative question we can answer is checking for brute force attempts and to see if any of them were successful. We can literally just do that by focusing on the SSH-related event messages and checking if authentication was performed. And we can see that authentication was performed at least 5 times from this internal IP address, and none were successful. Another thing, since we're discussing how we're comparing unified logs to EDR telemetry, something that EDR telemetry will never tell you, that EDR logs will tell you. In this case, we have a daemon that controls privileges on the host. And if you want to see what was provided to that privileges application, what the user might have said, and what reasons the user gave to get access to escalate their privileges, you can see it here. And I'll show you another example where you can see that AnyDesk being run. And once again, the predicate is provided here on the bottom of the screen. So another thing that EDR telemetry won't tell you is what permissions the application has and when they were enabled, when they were set, and what type of permissions are being used. In this situation, we can see that the AnyDesk application attempted to access the screen share capture permission via TCP, which is pretty much just Apple's consent and transparency platform to give whatever application you have on your host access to like certain features, whether that be like location access, screen sharing, logging in, things like that. And we can even see whether or not the screen sharing capture request was successful. And we can see it on this line here that it provided a value of 2, which means that it was allowed and went through. We can even see the results here below. So let's talk about private data logging. Private data logging is pretty much Apple's way of enabling privacy on the host, and it does that by pretty much redacting values, think like usernames, paths, host names, URLs, so on and so forth. And as opposed to just showing those things, Apple will just redact them completely, just providing the private as opposed to the actual name of the user who did the action. And by turning on private data logging, you pretty much remove the redaction string, and it's no longer enabled. But keep in mind that when you do enable private data logging, everything prior to private data logging being enabled will still be redacted, and everything after private data logging being enabled will now be redacted. Next. So how do we enable private data logging? The first way we do is that we need a profile, and we need to add the following dictionary to the profile as well. Then we need to add a mobile config extension to it, and we double click it, load it into the device management profile, enable it, install it, and then that private data logging is enabled, and we can see the exact user who accessed this host at that time. Other things we can determine now that private data logging is enabled is that we can look at a malware infection example. And in this case, we have a suspicious plist file that was installed on the 20th of August at around 9:06. And we determined this by using the launch control load predicate, and that pretty much just tells us what launch items were loaded into the system at like any time on the host. And we can see this suspicious looking plist file located in the launch daemons directory. So we want to investigate this a bit more. How about we pivot on the plist file? Pivoting on the plist file, we see a few things. We see mention of the plist file being copied from this temp starter directory to the launch daemons directory. Then following that, we see some permissions being added to it. And then finally, we see it being loaded into the system, hence the persistence mechanism being executed at the time of this log being logged. Other important things to point out as well is that in the unified logs, we can actually see the contents of that plist in the logs, and we can see exactly what it's trying to do. As we can see here, we can see that the launch daemon is executing a file named .agent located under the user's directory using min-mash. And we can even see the exact time the background task manager D process actually loaded this plist file into the operating system and fully executed it, allowing persistence to be established on the host. So what else can we find that OSHA script did? Because we saw OSHA script being executed on this host, and we can see that by here. That is the OSHA script process. And for people who don't know what OSHA script is on a macOS operating system, think PowerShell or Windows. It pretty much just allows you to run arbitrary commands on the host and execute them whenever you feel like it. So let's pivot on that process and see what we can find. When we pivot on that process, we want to look at like what was the first thing that OSHA script ran. We can do a bit of formatting here as well while we're at it. We can convert it to JSON. We could also look for how OSHA script activity is being logged by the unified logs, and that's pretty much just with this clone for compatibility function here. We can also access the event message and do some cleaning up. And after doing that, we can see the whole script that was executed, and the first script that was executed here was pretty much just a script looking for where the malware is stored on the host. Other things we can identify is what kind of commands were executed and what were the outputs of those commands. When you have EDR telemetry and it runs and you can observe a command being executed, you typically don't see what the output of that command is. With the unified logs, you can see the command being executed and you can see the output. And in the case of the command is above this slide here, but you can see the output here of some profiling commands. You can see the software version, you can see the hardware version as well. And this is another good example of how unified logs can show us things that EDR telemetry couldn't otherwise show us. Other things as well, we can determine what kind of malware this was, and we can determine that it was a crypto stealer because we can see some Binance-related files it's trying to access, along with some config files and the keychain database as well. Other things we can see it accessing Chrome cookies, history, so on and so forth. Pretty much just more evidence showing that this malware was an info stealer using the unified logs. Other things we can identify is evidence of exfiltration, and we can even see the command that was used along with the IP address and domain that it was sent over to, just focusing on just whatever OSHA script had ran once the malware had executed. And finally, if in the case you want to timeline all of the activity that you had observed during your investigation, you can literally just do that using double predicate commands and filter on the plist and the OSHA script activity, and you pretty much get a full timeline of everything the malware did. A few nuances to point out with private data logging is that not everything is redacted, even if you enable it. Apple has some proprietary URLs in this case, and we can see the MDNS responder process, which is pretty much just like a Apple's way of making DNS requests from the Mac machine to whatever domain exists. And we can see that some things are hidden by default, even though we have private data logging already enabled. We still can't see what's behind this domain. My theory as to what this could be is that this is probably more than likely Apple's proprietary infrastructure that they don't want anyone knowing about, hence why even if you do enable private data logging, you still won't be able to see what that is. So not everything is redacted by default. And also developers, or malware developers in particular, if they want to make their C2s unknown, even if you are using unified logs, they can literally just add a not sensitive field to their code, and even if you do enable private data logging, you won't be able to see what C2s were even communicated with. Other nuances as well is that you could, as opposed to enabling private data logging throughout your entire system, you could enable it for specific processes or subsystems as well, or even categories. A few other nuances worth mentioning. I mentioned a few prior. The first is that when you enable private data logging, everything prior to you enabling that is still redacted, and everything after private data logging being enabled is officially visible to you. But keep in mind, when you do decide to disable private data logging, it doesn't all of a sudden mean that that private data is just is gone forever. You very much do need to clear the logs to make sure all of that private information is just deleted. And also, it's important to note as well that leaving private data logging on also reduces the number of logs that are stored and shortens the retention period. Risks that are associated with private data logging is that if an attacker knows that private data logging is enabled in your environment or on the host system, they can literally just exfil or grab any authentication tokens, bearer tokens, cookies that exist on the host, because since private data logging is enabled, all of that stuff that you're doing on your machine, where you're making an API call or a request to a specific domain using a bearer token, guess what? That's being seen by Apple's logs, and it will be accessible to the attacker if they run this command. Other things is that they can see what passwords you're entering because Apple is logging that along with API keys and tokens. And unfortunately, I've ran this multiple times on my machine within the corporate network, and no detections exist for any EDR products that I've come across. Other things as well is that if an attacker decides to exfiltrate a whole log archive and use it to scope out your environment to understand what kind of hosts their target host is connecting to, what kind of infrastructure it communicates, they can just output the log archive, analyze it at their own time, and profile your network and get a good understanding of how it's laid out just by filling the entire log archive. And once again, no detection exists for this. Another thing they could do is that if they run specific tools or malware on the target machine, if they want to thwart investigators from analyzing the unified logs after the fact, they can just run log erase all, and you won't be able to get access to any of those logs, making the unified logs pretty useless in this situation. Think of it as similar to when you run this command to delete all the Windows event logs. Other things to keep in mind, let's talk about risk reduction here. When enabling private data logging, is the first thing you want to do is to ensure that private data logging is disabled everywhere else in your environment, and to regularly scan your log pipelines if you are collecting these logs for any credentials or any secrets that you might otherwise not want to be there. And also, if you do really want to enable private data logging, you need to make sure that you use a configuration file to just log only the things you want rather than log every single thing on the host. Other things to keep in mind as well is that if you do decide to enable private data logging, make sure to run log erase all after the collection to make sure no credentials are exposed and no credentials exist on the host after the fact. So this is how you disable private data logging, just removing the profile and running sudo log erase all. Keep in mind, you need to be really intentional with this, because once you run log erase all, everything is pretty much gone and you won't be able to recover it. So let's talk about log retention. So pretty much, let's say you're working an investigation where someone was using the screen share process, like I showed prior. If you wanted to see how long they were using that process for and for what length of time, The unified logs kind of makes it a bit hard for you because they're only retained for a short period of time. And as you can see here, on average, this specific process is only retained for 7 days. And it's also important to note that 7 days isn't a hard number. 7 days is very much dependent on like how much activity is occurring on that host, what's going on it, if the logs have been erased, or if the logs have rolled over. So like 7 days is more of an approximate number rather than the target. And an example of seeing what kind of things get retained and for how long, once again, we can see that most logs in this situation are retained for 7 days on average. Very few logs are retained for 14 days, and even less logs are retained for 30 days. So you can imagine that unified logs don't really retain data for all that long, and in situations where you want to use it for incident response or threat hunting, you kind of only have like a few days to work with rather than like a whole timeline of like weeks, months, or years to work with. So a few myths about log retention that I saw floating around the internet while I was doing this research was that someone was saying that a reboot wipes the unified logs. This is not true, and this has never been seen to be true. Another myth that I saw was that unified logs are stored for 30 days. As I showed you in the previous slide, on average, they usually are stored for 7 days, not 30 days, and very few logs are stored for 30 days. You can't save info or debug logs. This is not true. You can enable a log config to save these things directly to the host. And you can set your log retention period using log config. Unfortunately, with the unified logs, there is no way of setting a log retention period on the host. Like the log retention period is defined by Apple and it is updated by Apple. It's nothing that you could really control. So let's compare EDR telemetry with the unified logs. So a few places where the unified logs come on top is no API restrictions. When you have an EDR tool, unfortunately, they are very beholden to what APIs Apple will expose to companies and what APIs are available to developers to create EDR endpoint telemetry tools. And the vast majority of APIs aren't provided or aren't exposed by Apple, but a fortunate thing for the unified logs is that there is no log API restrictions at all, and it will literally log every single thing imaginable on the host. Well, with EDR telemetry, it's on Mac in particular, it's been shown and been seen to miss things quite frequently, especially kernel-level actions in particular. I'll show complete coverage as well. Everything is logged, nothing is missed, and you'll see everything imaginable. Also, zero deployment overhead. Once again, unified logs are available across all Apple products. There isn't an Apple product that doesn't have it. And it comes pre-built into the operating system, hence why it doesn't need any MDM configuration or full disk access. So let's talk about a few places where unified logs come short. The first place is there's no built-in detection capabilities with unified logs. Since there's such a fire hose and there's so much data, it's kind of nigh impossible to make detections on it unless you are monitoring the unified logs specifically and monitoring them for specific processes that you want to detect on. And it's also important to note with the second point as well, there's no adequate documentation from Apple on how to analyze these logs, and Apple typically updates and changes their API documentation on the unified logs. So if you have a way of detecting a specific tool that an attacker uses using the unified logs, keep in mind that when you update to the next iOS or like a MacOS version, that detection may be gone because Apple could choose to change how the logs function while they're logging. 1 week you can see a log logging an IP address, and another week it's gone. Another thing to mention is that there's no easy ingestion method for these unified logs because they are incredibly verbose and require substantial filtering with predicates before you can even put them into a seam. So these are all things to keep in mind. Now let's go to the takeaways. So we should use the unified logs as a collaborative data resource to establish ground truth on the host rather than looking at it as a full timeline of weeks or months or years. And also, when you're working in an investigation, you require the unified logs. It's very important that you export them as soon as possible to ensure that the data you need is retained and doesn't roll over or doesn't get deleted in any way. But it's also important to keep in mind that unified logs are a complete audit trail as they redact PII by default, which is like usernames, passwords, anything you can imagine that you do on your host, all of that, like any private information that you provide to your Mac, all of that is redacted by default, so it's not a complete audit trail. And also, if you're doing malware analysis on the Mac, enabling private data logging pretty much maximizes your findings, as you can see, as you saw with my malware example. So it's really good. It's really good for analyzing samples in general. So special thanks to all of these blogs because not a whole lot of places online have some really good Mac forensics guidelines or documentation or even research on it. But like these blogs have been more than helpful for this research. And finally, we're hiring in Poland. If anyone is from Poland, please reach out to me. So I'll feel free to chat. Thank you.